welcome everyone to today's MScAC Talks. This program is hosted by the Masters of Science in Applied Computing, or MScAC program, which is pretty unique in Canada. I'd argue it's unique in the world. The goal of the program is to train graduate students to take on challenges that society faces, that industry faces, and help them become better innovators and researchers. I'm really very pleased to welcome Professor Daniel Wigdor as our guest today. And Daniel is a professor of computer science here at the University of Toronto, working on human-computer interaction. He's also associate chair for partnerships and innovations in our department and director of research science at Meta's Reality Labs here in Toronto. One of the things that many of us know Daniel for is his immense success in creating startups. He was a founder of Tactual Labs, a startup that commercialized his research in novel human sensing, and also Chatham Labs, which was acquired by Facebook in 2020. He and his team's innovations are being used by billions of users around the world, and they help improve the way we relate to technology. So Daniel, welcome to MScAC Talks, and really nice to have you here today.
Well, thank you, Arvind. It's really exciting to come and get to be part of this community.
So Daniel, tell us a little bit about your experience in creating startups. Clearly, you've done it quite often, been very successful at it. How does this all come about?
Sure. So in general, I've got the research group at the university, and we've got 10 or 15 students at any given time who are research stream, graduate students, undergraduate students, et cetera, who are sort of pushing the limits of human-computer interaction. And so that means deeply understanding humans and our fundamental needs and capabilities, studying things like motor psychology, psychophysics, what issues like, what are really the limits of human perception, and then going out and trying to develop technologies that can address those limits more wholly, right? So as an example, the technology that gave rise to Tactual looked at the issue of latency. So when many people on the call know, you give an input to a computer, there's some amount of time between the time you give that input and the time that the results of that feedback reach your eyeballs. Finger to retina is how it's often referred to. In the physical world, that latency is zero, right? Like I push on a rock and the rock moves right away. So, for years and years and years, Moore's law comes, and doubling of the processing power, doubling. But for some reason, the latency of interactive systems was still just staying the same. It was right around this 100 millisecond, 60 millisecond. And what was really interesting to us about that was that people kept referring back and saying humans cannot perceive anything less than 100 milliseconds of latency. I've heard that, I've seen it in software engineering books, I've seen it in HCI books, where is it? And what we really dug into to understand it was that was based on a study done about 35 years ago now, where they basically, you would flip a light switch and then how much later the light would come on. They would add a delay and then measure how quickly you could detect it. But now with modern computing, we have, it isn't just you push a button, you sit back and you wait for a response. You're actually giving an input continuously, right? Like I'm drawing with a pen or I'm sliding something with my finger. And that latency, is just so apparent. So we wanted to really push and see, what are the limits of perception of latency? And we found it was really more like people could perceive down to 1 or 2 milliseconds in those interactive computing scenarios. And then dove into, how do we actually build a system that could give that kind of latency, and sort of built out the technologies. So, as an example with Tactual, one of those technologies was a fundamentally new touch sensor that used similar to but different technology than the touch sensors in our capacitive devices today. And, it was just along the way what we had to do to get rid of the input latency, but we developed it, we patented it, and then, found some interesting uses for the technology. And so it spun out that way. But I think it all comes from a curiosity about capability and how can we really tweak the technology, and then it sort of can flow out of the lab when there are commercial applications.
So as you're talking, I think of two things. One is you hear that you should always start with addressing a challenge that the world needs solved. But here you're asking a pretty fundamental question. Can you reduce that latency? Did you think about, is this something the world needs ahead of time? Or did you say, wow, this is a really cool question. Let me see if we can get on.
I think in that particular instance, it was, I was just being driven crazy by the latency of the system. And so it was, it was just like an itch I had to scratch, and just it drove me crazy. Because when I was an architect at Microsoft for a few years on the product side, developing the first Microsoft Surface devices. And I would engage with these teams, and I would see that this latency was coming from the stack and how the modules were getting developed, which was doing the right thing for software engineering, and blah blah blah. But I just couldn't get traction behind really trying to tackle this latency holistically. So in that instance, it was I just have this instinct that we can create a better experience for the user in this instance. But certainly, like, in that instance, we're making touchscreens, better and faster and, more fun to use. And, but we also, of course, also examine the flip side. So I've got a student who now just graduated as professor, but he was looking at how is misinformation making its way through Chinese social media tools, and what are the ways that we can, learn about that and potentially have different tools to overcome the misinformation. So, it can also come from more noble pursuits as well, I guess.
And what I think clear to all of us is that just because you have this great idea and the world might even need it, that's not enough to be successful when you roll these things out. So tell us about your experience taking, let's take the tactual example. Mm-hmm. In taking this idea, you've got some new ways of reducing latency. What does it take to make a successful startup?
Yeah. Well, I won't deny that luck plays a big role, but I'll share what I can about our experience. So, the first thing that before the idea, before the technology, all of those have to happen and it's table stakes. I'll talk about that in a second. But first, it's the team, right? Like when you're creating a startup, these are the people you're gonna be in a foxhole with. These are the people you're going to be, coming to the office and seeing 60, 80 hours a week when you're trying to, first get this stuff off the ground. And so, finding the right mix of people who can have a passion to drive the technology, but also can sort of step back and understand the context of that technology, so that they're not, just sort of blindly pushing ahead and saying, no, you have to, fundamentally change the architecture of your system or else none of this will work, right? Sort of understanding the trade-offs of things. So it's sort of that blend is really important in a team. But then, once you've got the team assembled, the other thing that I had this really eye-opening experience when I was first going to work at Microsoft. I did my PhD in computer science. And, when you're doing research in HCI, at the end of most of our papers, this is the section called design recommendations, right? So I'm doing all this generalized research, but then I'm trying to distill it down to a few teachings that people might apply. And I actually thought that HCI and, computer science literature had this dialogue with people in industry where, like, okay, Microsoft, Apple, whoever it is going to make a product now. They're going to reach up and get the proceedings of our conference and read our design recommendations and then just sort of do what we say, right? And then, I got to Microsoft and realized that, like, they are tackling exactly the same things in many instances that I did my PhD, but they've never even heard of these conferences or journals, right? Like, it's all from scratch. So I think the other piece that's really important, one, I think there's a lesson there for research and how we can engage the community more. But I think the other lesson to take away is understanding really what are the constraints that this is operating under, right? And I think, with Tactual, the first sort of failure case we ran into with it was we tackled sort of three different areas of latency. It turns out in interactive systems that, not surprisingly, it comes from the input, the processing, and the output, if you go back to that old model of computing, right? So I talked about the input sensor. The other thing we developed was we re-architected Android to get rid of a bunch of the latency in Android. So we had this new version of Android that we wanted to share with people that, was sort of research grade, right? Like, not ready to be deployed. And we brought it into to Google and said, hey, you should do this thing. And they got all excited and, maybe we can make this happen. But what I came to realize very quickly was that the reason we could get rid of the latency was that we were breaking down the modules that are developed by different teams. And that a lot of the software engineering that goes into this is a reflection of like organizational structure as much as it is good software design. And so we didn't have a customer for that technology because there was no one at Google who was responsible for doing the overall architecture and getting rid of latency. And instead, it was just these individual product teams, and we weren't solving any of the problems any one of them had because it was about how does it all come together. So I think the other big piece of the startup is not just understanding the human need and what is the problem my technology solves, which is incredibly important, but also what is the business context that I'm sort of walking into with this, and how do we really address it? The software product totally failed and we dropped it because if Google wasn't the customer, who was going to be the customer, right? So we moved on. We focused on the sensor.
And where did you find all these people? I mean, where did you find this team?
Since I've become a professor, my startups are all co-founded with students and postdocs. So Tactual was co-founded with a friend of mine from New York City who was a finance guy but really wanted to come and run a company. And Ricardo Joda, who was my postdoc at the time, got really excited about it and wanted to go start it. Chatham Labs that you mentioned was largely populated by graduates of either my group in particular or the larger DGP, which is the larger group that does HCI work in the computer science department. And like half the company was people who were alumni from the DGP lab. So a couple of things, right? One is these people are clearly aligned, and you've spent all this time working together, and you can sort of understand each other, and you understand the puts and takes, and they deeply understand the technology and the problem. But then the other is, I think we have a responsibility as faculty. We can start companies and make money, and you can sort of go off and do this thing. But I think I think there really is a duty to serve to the students, to give them these opportunities, right? So I sort of view it as both of those things.
As you're talking, Daniel, one thought I'm having is that so many people say that you can't focus too much on the technology. You can't focus too much on the research, and a lot of startups fail because they get enamored by their technology. But your startups have shown that being technology focused, really cracking hard problems, is a good way to build a startup.
Right.
So would you say that the VCs who constantly tell us, don't think so much about research and technology development, just think of how to take almost existing off-the-shelf products and repackage them in a different way, that they're off base here?
I genuinely believe it, although the other secret sauce maybe of my startups is that they're almost entirely self-funded. So I have not sought venture funding for any of my companies, and and I think the reason for that is you look at what venture is looking for now, right? Everyone has gotten hooked on what used to be called the Mirabilis model, right? Which was that Israeli company that created ICQ, which is one of the early chat clients. And they very publicly said, our goal is to get a whole lot of users so that we can sell our product to someone. And what we're actually selling is our customer base, right? And then America Online bought them, right? And this was like a radical idea in computing, that your business model is around getting sold as opposed to actually being a successful company. And yeah, the VCs get hooked on this, right? It's like, what's the quick return? How can we flip this? What's the big tech company is going to buy this? And I think part of the lesson in it is you have to understand what is your technology really trying to accomplish. So you're not just navel gazing and, hey, look, I can make this faster, right? But yeah, I think there's a ton of pressure from VCs to get that really quick return. And I feel like a lot of the VC money isn't actually venture capital anymore, right? It's something very different from that. It's corrosive, I think, in a lot of ways. You have to be really careful who you're partnering with in your funding rounds.
Yeah, and the argument's been made that Toronto and Canada are actually farm teams for the big US companies, and with a huge amount of government subsidies for Canadian startups, this is a cheap place to buy up technology and people. which is, of course, what we don't want, right? We want to create some real homegrown talent here and homegrown companies. Tell me about your graduate students. Do you mentor them in entrepreneurship, commercialization, or does it come naturally because of the kind of research that you're working on with?
Yeah. I think it depends very much on the student. So, as you, of course, have had this conversation with students over the years, what do you want to do with your life, right? And you've got the ones who want to go and be a professor, and that's the goal. And so, the focus on that is playing that game. But certainly there are students who have wanted to join the group because they've seen that there are, there's this sort of commercialization arm of the stuff that we do. And I think the mentorship that I try to offer them is in a couple of ways. One is sort of in the principles that I've sort of talked about. But the other is to really have a big emphasis on internships and going off and being in these companies. And I think that's just something I've been so impressed by with the MScAC program, and the caliber of internship opportunities that you guys create, not just with like who's the company, but the process. I'm not, what is it? I'm not only the hair club president, I'm also a client. So, I've had several MScAC students come and work at Tactual, and we're now bringing them into my group at Meta Facebook. And the onboarding process isn't just, hey, post your job, right? Like, you guys are vetting. You have to pass muster to be allowed to show jobs to these students. Good, fabulous, right? Because I think you're creating not just opportunity, but the right opportunities. So, but anyway, back to your question about the students. Yeah, I mean, it's just that. It's about putting them in front of the right people and getting the right experiences.
Yeah, one thing that I think about sometimes is that, especially in the US, but increasingly in Canada, there are graduate degrees oriented around developing technologies or new ideas that could be spun into a startup. So the entrepreneurship is an integral part of the graduate degree. We haven't done that at U of T. What do you think? Is that a direction we should be thinking about?
I think I think thinking about it, absolutely, right? I mean, the way commercialization in Canada is so slanted from, the funding you can get from government all the way down to trying to create something to enable an existing company, right? And I haven't looked at the MScAC programs recently, so this may be a false accusation, but there was a period of time where they had this Engage program, right, that was meant to sort of help foster things. But one of the very early hurdles was that you needed to have a company that was going to invest in the technology, but the company couldn't be owned by the researcher. It's like it was supposed to be this thing that would help spin out technology, and the only way you could do it is to give it to someone else, right? Anyway, so it's so slanted against. So you see the success of those programs, and I think that gives you a couple of things. One, there's such great talent, at U of T, at Rotman and computer science and other places that sort of have these experiences and can apply and sort of show how you can make it work. I think the other thing that creates, though, is the sort of research oriented stuff that I think that would really make for a proper PhD as part of that needs runway, right? And as I've said to my students, you've made a decision here that you're getting funded, $25,000 a year or $30,000, whatever it is, instead of going and getting a job in big tech or at a Canadian company and making $120,000 a year out of the gate, right? So you're choosing to make that sacrifice. But the opportunity that affords you is you can focus on nothing but this thing for this period of time, right? That's the gift of the PhD, which is sort of the same thing as the gift of the startup, right? Is that you sort of made that choice and you're sort of focused on it. But it sort of creates an environment where you can, there's the whole fast failure ethos of Silicon Valley, right? But it gives you this chance to sort of take more time to develop it, along the way. So yeah, I think it'd be a tremendous opportunity for sure.
Yeah, and because we get so many wonderful students from around the world, talk about mixing different ideas that emanate from whether it's India or Taiwan or Africa, and there's huge opportunity there. I'm just going to shift gears a little bit and talk about Toronto. Toronto has really emerged very quickly as a major tech hub. I think in 4 of the last 5 years, there were more tech jobs created in Toronto than I think I read Silicon Valley, Seattle, Washington, and New York combined.
Mm.
And now we're approaching 300,000 tech workers in Toronto. What happened? How did we come? 15 years ago, Vancouver had a bigger tech scene than Toronto.
Right.
Today, we're many multiples bigger than Vancouver, Ottawa, Montreal, approaching, not the size of Silicon Valley, but within spitting distance. What happened? What created this energy?
Yeah, well, I mean, fabulous question to examine, right? I think for me, the sort of secret sauce of Toronto is exactly what you mentioned a couple of minutes ago, which is that we are this international city, right? And I think back to the companies that I've created and the ones that I've been collaborating with. So often it's people from mixes of backgrounds who have immigrated to Toronto, and that's just part of the culture here, right? I grew up around here, and I remember the first time I moved to another city, and I found it I walking down the street, I felt very uncomfortable. I could never really understand why I felt uncomfortable, and I finally put my finger on it. It was that everyone was speaking English, so I could understand all of their conversations as I was walking. So I felt like I was sort of spying on them. Whereas in Toronto, like you just this beautiful mix, right? So I think there's sort of part of that. I think there's recognition that we have fabulous universities here and really strong tech talent and a desire to create opportunities in the city. And I think that there, it sort of is seeded to some extent, as I forget if you said farm operation or what term you used, but big tech can sort of establish their hubs here, and people go and work for those companies. And as you said, that's undesirable, maybe, in the sense that what we want to do is to foster talent and create something properly Canadian. But I think the other thing that really, what can create this exponential growth is you have to have the critical mass, right? And what I mean by that is not just the number of people, although that's important, but it's also the number of jobs, right? So when I'm trying to recruit someone to come and work at one of my companies, and they're also considering moving to San Francisco or Seattle, two that you mentioned, part of the sales pitch is not just, hey, Toronto's a great place to live, but it's Toronto's a place you can get another job if this startup fails, and you won't have to rip your kid out of school and take to relocate, right? So I think that there was sort of this sort of safety net gets created. And I've used it very explicitly, actually. When Chatham was first booting up, we were doing a lot of research in HCI, and one of the big research centers in HCI in the world that is Autodesk Research down the street from U of T, and a lot of our alumni from DGP are there, of course, as you know. And I called up, I was trying to bring people in to interview at Chatham, and I called up the head of Autodesk Research in the Toronto lab and said, hey, would it be okay with you if every time I'm bringing someone in to interview, I tell you about it and we coordinate so that you can interview them also for the position? And at first, that sounds crazy, right? Like, maybe isn't part of what you're doing like protecting it, right? But if I can't give a better option for someone than a big tech company, then what are we doing, right? But again, it's that we've gotten to that critical mass of the culture here, and there are enough jobs that there's sort of this safety, and you can sort of build from there. And then, of course, aside from the universities pumping in all this great talent, we also see the effects of venture money starting to get more sophisticated in Canada. You're seeing, it used to be a lot of the venture stuff here was would never lead rounds, but they'd be followers in rounds. And, you're starting to see more and more of it actually, being led here, which is really exciting. Which makes sense. I mean, Toronto is a fiscal center of North America, right? I mean, why it took so long for that to happen is a little crazy. But
second largest capital finance market in North America, so after New York. And one thing that I find interesting is that a lot of the international students that come study at U of T are thinking this is a launching pad to make their careers in the US, and they get here and they say, actually, I want to stay in Toronto. In the MScAC program, 92% of our students end up staying in Canada, almost all in Toronto. I mean, just a phenomenal number. So Toronto's clearly doing something right. I want you to just comment a little bit, you're right. It's that right mix of startups, large companies, small companies, international companies. At first, we were seeing this phenomenon where some of the US companies were using Toronto as a way to bring in international workers who couldn't get an H-1B visa or J-1, whatever visa to the US. Do you still see that happening? Do you see that that's changing?
Yeah, and of course you're right. They get they couldn't get the H-1B, but if they work for the company for at least a year, then they get an L1 sort of automatically, right? Then they can make their way to the States. So it's sort of this automatic, you put in your year. Um, I think less and less of that, very famously, and there's a lot of that in Vancouver, especially for Seattle-based companies. And, even there, a couple of them have been sort of closed down over time, not in the sense that the companies aren't interested in investing there anymore, but in the sense that they don't just see them as a way that people can work remotely, but they're actually seeing the sort of unique perspective and talent that could be provided. And, I think in a technical sense, there are so many areas of computer science where we're pumping out graduates that are totally world leading, right? Like we're seeing obviously AI and all the great work around Jeff and others in the department, and how that has really landed. And he's, this whole ecosystem of students and their descendants that sort of, has converged and remained in Toronto. And of course, there's all, out of the DGPs I've talked about, we've got the HCI group and also graphics. The technical director of Toy Story is an alumnus, and we've got a big Pixar connection and connected to the film industry now in Toronto. More and more people there. So anyway, yeah. So I think we've sort of gotten past that point to a large extent, right? I think certainly when I was talking to tech companies on behalf of the department about establishing hubs in Toronto, the conversation is never about, hey, can I get a WeWork there and just park people? It's about, what is unique and special about Toronto? What should we be emphasizing in terms of our hiring? What are the groups we should be trying to build? So I think there's a real recognition now of Toronto as a center of tech and of Canadian values, frankly, being important to the future of a lot of this stuff.
And talk about U of T. I mean, many companies say that U of T is a little standoffish, hard to work with. We constantly are hearing in the MScAC program about Waterloo. Sometimes we even hear about Ryerson. Ryerson is so much easier to work with. Where's that coming from? Do you find it's true? I mean, when you put your industry hat on, that this university is not so easy to work with?
Well, it's a monolithic thing of tens of thousands of people. So, but if we're talking about the normal distributions, where is the center of those normals? I think a lot of it, there are a couple of things. I mean, Waterloo has obviously had their co-op program on rails for decades now. And, their alumni are now heading companies and hiring people. And naturally, they're sort of a draw for that. And they've got the process so on rails, right? You post a job, you hear your interview slots, and the process is very facilitated in a lot of ways. And, MScAC is a great example of where I think Toronto is sort of changing in that way I mentioned it was hard for us to be allowed to show your students jobs, but once we do, the process is very regulated and easy to understand, right? There's a good onboarding process. I think what U of T has sort of traditionally been good at is having sort of solving problems that companies don't yet know they have. And doing that sort of innovation. And I think there is sort of a cultural thing around, I've heard people say, I don't want to solve companies' problems because they're too short term, right? And I've heard that from people. And, and then I always tell them the story of the transistor, right? And how, it's hard to say that the transistor isn't the most influential piece of technology developed in the last 100 years, but, certainly in the top 5, right? And of course, as comes out of Bell Labs, and the work came from not because they were trying to create a unit of computation. They didn't think they were inventing a computer. They didn't know they were inventing a computer, right? They were given the problem of, this was back when the way that telephone calls were made was you actually had to connect a circuit, right? A circuit switch network, as you know. And it is sort of the mechanical equivalent of those old movies with the operators with the plug boards, right? But you're doing it mechanically, but the mechanical switches were failing all the time. So can we get rid of the mechanical aspect but still maintain the switch? And that's what the transistor was invented for. And then only after that did they realize it was for computation. So I think U of T could do well to be interested in hearing more about problems and investing in trying to solve those problems and seeing where it can lead. And that's what we're trying to do in the office now, in reaching out to companies. And then I call the responsibility of my group to solve the impedance mismatch between U of T and the outside world, just to get the expectations aligned, and to help facilitate those connections a little bit more so they can understand each other. But
Are you finding receptivity? Are you finding the graduate students and the faculty are keen to get into these conversations?
I think graduate students, absolutely, because they've got problems there, and hey, I see how this is interesting. I can see immediately how it's impactful, and application domain stuff, that might not be relevant for the fundamental computer science questions, right? I'm solving some file system problem, and it doesn't matter if it's a nuclear plant I'm solving it for, or a social media company or whatever. But I think they get really excited about having this sort of domain. I think with faculty, it's sort of bifurcated. There are faculty who believe that that we should have this deep engagement, and there are a bunch of faculty who, like me, or sort of have split appointments, or they're not called joint appointments, but sometimes people use that term. Where people are working at a company significant amounts of time. We're leading, our faculty lead the local NVIDIA, Samsung, Google. There are other examples I can't come up with at this moment. But anyway, there are faculty who sort of deeply engage, and then there are the others who I think have a reasonable skepticism around seeing how commercialization has like filtered money and prevented them from being able to do their best work. And so I think they sort of have that experience and engage it with that skepticism for a reason. And we're trying to bridge it, and mixed bag so far, but early days.
And maybe the younger faculty than the newer hires are much more curious about these things, right?
Well, I do notice an age effect too. Yeah, absolutely. Or I'm sorry, career stage effect, it's not age.
Yeah. And so you mentioned this sort of appointments of faculty across the academic industry divide. We probably haven't, as a university, been the most progressive at encouraging this kind of behavior. Yeah. What's your view on that? Should we be more encouraging of people getting joint appointments between industry and the university? Is it the death of us, the university, if we have too much of this? I hear both arguments.
I think there's legitimate concern, that it can possibly have corruptive influence. I think in some disciplines, you can imagine, I'm working for a drug company, and that's reducing the likelihood that I will, do the research that shows that their drug is ineffective or harmful or whatever. I think there's sort of that potential effect. And then I think the other potential effect that I think people are legitimately concerned about is, to what extent will industry influence shorten the time horizon of the work, right? To your point about the startup and the short term versus longer term research. I think a lot of collaborating with industry is helping them to understand their problems as much as is finding solutions to the problems. And if instead you're just sort of answering the problems, then I think it can move shorter term. I think the flip side of it, though, actually, I should say also, funding in Canada has been so skewed towards being able to demonstrate a customer for your research for quite a while now, that I think that effect has sort of already taken place to a pretty significant extent, certainly in computer science, as of course you know about. But on the flip side, I think it gives us incredible opportunity in a couple of ways. If you can handle it right? If you can grab the tail of the dragon, or where the right metaphor is for it. I think one, it lets people have a real connection and have their finger on the pulse of what's going on in industry and understanding real problems, right? By having faculty who are heading research labs for, I'll pick on NVIDIA because I genuinely have no idea what they do at the NVIDIA Research Center. So I can't possibly, get anyone in trouble. But if you're engaged in doing your machine learning AI work at the place where they're designing the architectures for the chips that are going to be enabling AI, think about the opportunity that unlocks and how you can bring those challenges to your students and sort of ground your research around those things, right? Incredible opportunity. And then of course there is there's a long history of faculty engaging with the world beyond our day jobs. And that's a really important part. The governing council refers to it as a critical part of disseminating the results of the research lab. They're not referring to the split, where you actually have an employment contract with the outside world, but they're talking about just in general engaging with industry in paid activities. They use that phrase. So I think the flip side is you can actually start to drive work from the research labs and really start to change, industry. See my earlier point about, publishing papers, but who's reading them? So, I think really good opportunity, but we definitely have to be careful of managing it. I think there are definitely legitimate concerns for sure.
What's next, Daniel? What other exciting new ideas do you have? Are you thinking of more startups? Are you going to let us in on the secret?
I've got one more startup that is going at the moment that is called Trace, or it was, if you Google it, it was called Atom until fairly recently. This is a great example of a startup that, it sort of comes from one of two places, right? It's either an idea or a problem that I'm really passionate about and tackling, or it's something that comes completely out of left field that one of my graduate students, is driving and really, doing the work on. And this is in that second category. So I have a PhD student who developed tools to do prototyping of hardware. So, we've gotten addicted to in computer science, and we teach methods in computer science around this idea that you can, test your software in like real time, right? Which is a relatively recent luxury in the history of computing, right? But hardware, people who are doing prototype hardware don't have that luxury. You can simulate, but nothing, beats the real thing if you get your hands on it. So the way that people have to build those technologies today, if you want to prototype it, is, you lay out your printed circuit board in software, and then you identify your components in software, and then you place your orders, right? You send this off to the PCB, the person who's going to etch your circuit board, and you place your order for the parts, and then you can either get someone outside to assemble it all together, or you get it and solder it all yourself. But it's like 2, 3, 4 days. Imagine anyone on the call who is a computer scientist. Imagine when you hit F5, you have to wait 3 days before you can test your program, right? And back to the days of punch cards and getting computer time. So he developed a technique that would let you create a printed circuit board in about 60 seconds. We use a technique called photolithography, where you have a special sheet, a special stack of a few layers, send it through an inkjet printer, and the inkjet printer prints the negative of the circuit board, and then you expose it to UV light from the sun or from a UV lamp, and it cures the glue that is sticking to a copper layer underneath, but not where you've masked it, right? So then you can just rip it apart, and then you've got your circuit board sort of left behind, and it has ripped away the other pieces. And this comes from photoablation, sort of in a manufacturing process, photolithography. But anyway, we put it into the home, right? So for $5 you can buy one of these sheets and do the thing. So it started there, and then he has sort of expanded that with a CEO that came out of the Rotman School's program. They partnered together, and they've expanded it now to do other rapid prototyping technologies. So they've got a machine that will actually, put your, not only do you get the circuit board, but now if you've got your parts and they're loaded into one of these cartridges properly, it'll like put them down and do the soldering for you to sort of make it work. And again, trying to get to this place where you can hit F5 on your hardware and you get it within, like shorten it from days to hours or minutes, right? Like to do that cycle. Anyway, so that's one that's sort of still ongoing. While I'm working for Meta, I myself am not starting companies, but I think to me the really fun research that we're starting to get into is sort of a couple of places. One is we've got this huge opportunity with AI to advance human computation, right? And humans' relationship with machines. And one of the things that drives me absolutely crazy about the way that people think about how AI is going to be integrated into the system is that it's going to be this like personified fake person who I try to have a conversation with and convince them to do stuff for me. Like, it just drives me bonkers, right? Because even when you're giving a talk, right? We're doing a fireside right now, but if someone was doing a talk, you'd have slides. Right. So like even humans don't just communicate with verbally. So why are we trying to get the computer to do that? Right. It's just silly. So I'm spending a lot of time working on, how do you deeply embed AI into interactive systems, and how do interactive systems fundamentally change? And then how do you make interactive systems working with AI as ever more powerful tools in control of the user, as opposed to me having to sort of step back and have the machine do it for me. So I think that's a really exciting area of like, how do we really blend AI and HCI into something genuinely that advances human thought, building on the ideas of Engelbart. And then I think the other place that I'm really excited about is multimodal interaction, is being able to achieve like symbiotic relationship with haptics and try to do immersive experiences and things. But it's very much in those are sort of like the HCI, pure HCI stuff I'm playing with these days.
Wow, it's really exciting, really, really exciting. So I'm just mindful of the time. We have a bunch of questions that are in the Q&A, and also I noticed there's a couple of questions in the chat. I'd invite everybody to put their questions into the Q&A so we can go through them. And so Daniel, I don't know if you can see them in front of you.
I do, yeah. They've been popping up. I have not been reading at the same time, but I've got them now. Yeah.
So, give you a chance to look them over, and I'll talk really slowly so you can decide where you'd like to go with answering some of the questions. But yeah, so turn the floor over to you to give us your thoughts on some of the questions the audience has been asking. Okay.
Yeah, happy to do it. So just, I'll start at the top. I see Nikhil is asking about, how do startups compete with big companies? Is sort of how I'm seeing that question. I think honestly, you'd be shocked the extent to which it's really the big companies trying to compete with the startups. And what Chatham, the second company that we've talked about here, Chatham Labs was not a company that was developing a product. We were doing tech consulting. So basically, we were a research center for hire. And we had a bunch of people who were doing fundamental research in computer science, and we would find clients who had problems, help them to understand how research could solve their problems, and then attack it with a research approach. And what was really interesting to me was when I sort of pitched this idea that you're going to outsource your research and development center to another company. The people who run divisions of the big companies said, that's crazy. I would never hire you, right? Because, the core technology is too important to me, and I can't let it be outsourced. And besides, this is the kingdom I'm building, and I'm the one inventing the future, right? Their bosses, the people who run across divisions, they couldn't get enough of this idea because they see it as, our divisions are too staid, they're too slow, they're too mired in process and politics, whereas I can help, I can get this nimble access to these ideas that can quickly pivot and really help us getting onto the cutting edge. So, I think the big, the way to compete from my point of view, to answer the question, Nikhil, is to really take advantage of the opportunity of being a startup and not just looking for the short term, what can I solve quickly by, doing a slightly different something that the other side could just do, but, by really investing in building fundamental technologies and taking advantage of this opportunity. I think that's a really big, important one. So I'll move on. Celeste is asking, yeah. When startups are staffed predominantly by students, how do they adjust to the realization that industry may not be up to date with recommendations from research publications? I think when they first learn it, they think, oh my gosh, this is going to be easier than I thought it was. Because, your research, you're a student, you're like, you're doing your master's on a topic, that topic better than anyone in the world. Right. And the difference between a master's research and PhD research is just about how broad it is or how deep it is. But you were the person who spent the most time looking at that thing. And you go off and find out there are these problems you need to solve. And you think, oh my gosh, there's this paper from 10 years ago that shows how to solve that problem. They just don't know about the paper. Right. So I think the bar of what is innovation in industry in many, many, many contexts is much lower. So I think there's that aspect of it. I think but the reverse of it, Celeste, is when students realize that the outcomes are different, right? Of thinking back to my Google example with Tactual, understanding that the problem wasn't the technology. The problem was that we were competing. We had no customer for the technology. Like Google as a company should have been, but there was no single executive sponsor who could be the customer of that technology. So I think it's about that mishmash. How does I see a question from Christine? Do you want to just keep firing off, Arvind? Is this a good?
Sure.
Okay.
This is great.
All right. I see Christine is asking, how does research work and what opportunities are available for undergraduate students? So about half my research team is undergraduate students. And so, how does it work? There are big research problems that people are interested in taking on. In my lab, there's sort of two extremes of if I can just make a parody of professors for a moment, right? One is the professor who has a singular vision, and you will come in and you will figure out how to mix this one chemical in exactly the right way so that I can solve my much bigger problem, right? Then the other extreme is people who are just sort of totally intellectually curious, do whatever you want. It's computer science, it's history. This is the advantage of being in academia. I'm much more towards the second of those two. If only now, because I've got my group at Meta with 100 people sort of tackling the big problems that need big problems. So in terms of my research group, I and I think most other faculty think of our jobs as helping students to find their passion and to really drive the work that they want to do. For undergraduate students, it's usually about looking at the research that's going on for me or anyone else. What are the projects that are coming out of the labs? But then also noticing the projects that you look totally different from each other, right? Like I mentioned, we're doing work in social media posts in China about COVID, and we're also doing printed circuit board manufacturing, right? But the common thread across all of that is, what are the opportunities for technology to genuinely improve people's lives, right? Either because we're helping you to get better information about a killer disease, or because we're going to help you to build your tech faster, right? And I think there's connective tissue that's different for any given lab. So it's about really understanding what is that connective tissue, and then approaching faculty. And at least for me, I get cold calls from students constantly. I think I know every faculty member gets cold calls from students constantly, and I certainly answer them. Anyway, so that's an opportunity. About the products. Are your products selling the patent? How do you create the business plan in terms of financial statements if your startup company is self-funded? Yeah. Cool question. My sort of hobby was engaging in intellectual property lawsuits. So I testified an expert witness in a lot of big patent cases, like when Apple and Samsung were going after each other about 10 years ago. I testified in that case, and I overestimated the importance of patents before I got into it. So I also fundamentally misunderstood what a patent is. So patents for a startup are important in that you need to protect your core invention, and investors need to see that there is some amount of protection. And the how far you've made it through the patent office sort of impacts the degree of that protection or degree of investor confidence. You don't have to have an issue patent, but a couple of office actions at least back. But what it doesn't do is say that you won't later get sued, right? Like people say that patents give me freedom to operate. They absolutely do not do that. So you have to just dispel yourself of that misunderstanding of patents. It's just you are allowed to have exclusive domain over this thing that you have patented. So what are we marketing the patents? At Tactual, we were not really. We had patents that covered our technology, but we had actual technology. And I've had people approach me a bunch of times and say, "Hey, I've got this patent. I want to license this patent." But there are two problems with that as a business model. One, if you're not in pharmacy, a patent only covers 1/1000th of a product, right? The iPhone famously had 6,000 patents when it was launched, right? Steve Jobs put that on the slide in the presentation. And, so it just isn't, one patent isn't enough to solve enough of the problem. And two, if you're doing really cutting edge work, even with the patent, I won't be able to reproduce it. I won't be able to make it work. I need the team, right? Like I need to collaborate with you. Like you need to actually make it. It has to be, it has to be made. So, there are certainly companies like Immersion out of Ottawa that have made a lot of money as patent licensing entities in recent years in Canada, and Qualcomm in the state, like lots of examples, right? But as a startup, it's so expensive to maintain the portfolio and hard to get investors, and ultimately, really hard to have conversations with people who might be licensing the technology. So I'm a big believer in selling stuff and the services of people rather than patents. Okay. Sorry, they've sort of refreshed as I've been talking here. Arvind, are there any questions in particular that leap out at you that you think I should speak to?
Well, there's some interesting questions here about how you handle IP, the separation of IP in your startup and U of T. And I think a lot of people are wondering, how does IP work? Because the university would want to cut if it What's been your experience with IP?
Yeah. So universities take, again, two extreme views of this, right? There are the Carnegie Mellons that like try to lock everything down, and they themselves want to be licensing and sort of, perpetually part of the action. And then there's the other extreme, places like Waterloo, that say, take it and go, do your thing. When you make a big donation, we'll name a building after you. And I think for the health of the ecosystem, the latter is much more effective. Right? Like you look at the ecosystem that Stanford helped to create, professors played a role in a lot of those companies. And, there's a reason that Larry and Sergey were still doing their PhD and continued with it when they were starting Google. But, but I think, not trying to like get in the way is the right approach. And U of T has a pretty, it's much more similar to the Waterloo example. It's not quite there. But U of T, just, at a high level, if people are curious, U of T takes a substantial use of resource model to determine IP. So if in creating an invention, you used substantial resources of the university, right? Like the pay for your graduate students, the lab, the computer that you used, right? Like you actually used U of T resources to create it, then the university owns it and you go through their process. And U of T gives you most of it back. You can take what's called self-assignment. Or if it's not done at U of T, then they make absolutely no claim. And that's a very healthy model for creating an ecosystem, because it gives faculty and students the freedom to do things simultaneously without the sort of specter of IP, problems down the road. So U of T has been really good about that in their model.
And do you find that having U of T as I guess, an investor owning a piece of the startup, that's actually helpful for outside investors, or does it hurt?
I think certainly the research comes out of a university like U of T is incredibly helpful, right? Because investors are always looking for a stamp of approval, right? So like, and that's why they ask deep questions about like, who's the team? Where is their degrees from, right? Because like, how do they get there? How do they know? Like they get 1,000 pitches that all look like world-changing tech. How do I know that this is the one, right? So having, being able to say this came from a U of T lab, that's absolutely worth something. And it can come along the way. U of T actually owning shares, U of T is good about not trying to get special classes of shares or, do things that might mess up your ability to finance later. So they sort of get out of the way. The actual ownership of the university and the company doesn't have a big impact, one way or the other. But I think, having the blessing of a university like U of T is really important, really valuable.
We're almost out of time, so I'm just going to sit down to the last question.
All right.
About the direct computer-brain interface. To get rid of bandwidth issues. Have you thought much about that? I mean, it's definitely an HCI issue. And is that the future of HCI?
I'm trying to remember what has been said publicly by my current employer as I sit here. Mark Zuckerberg has talked publicly about electromyography as a technology being a way that we can, bridge physical sensing of traditional HCI and eventually create a direct brain interface. I am increasingly a believer in the potential of that path. And you never even, the problem with a tool is not so much about bandwidth. It's about creating a representation that people can understand and work with, right? Like there's a reason it's easy that Arabic numerals survived and Roman numerals didn't. It's easier to do math with them, right? So, there's value in like the symbology and the form of the tool. So it'll never, brain doesn't mean just like get out of the way and let the information flow, but it is there's a lot of really big opportunity there for yes, increasing the bandwidth. So yeah, I think whether it'll go from the realm of science fiction to reality is a question to be examined in the future or on an ongoing basis.
Well, on that note, I want to thank you, Daniel, for being here with us today and sharing your insights, and maybe inspiring some of the younger people in our webinar to go out there and follow their passion, develop really cool, cutting-edge technology, and not give up in trying to commercialize it and not do the short-termism, because the big breakthroughs happen by following your passions.